All right, this is the last section we're going to cover in our chapter 3 unit, and I know it's from chapter 9, so don't be alarmed. So we're going to use the information that we just talked about when we were talking about graphing lines. Now we're going to graph linear inequalities. So the only difference is instead of an equal sign, there's going to be a less than or a greater than sign, or less than or equal to or greater than or equal. So there are a few details when it comes to graphing these that we need to talk about. So I want to talk about those. So you'll definitely, if you have some graph paper, definitely might want to take some graph paper out. If you have some colored pencils, another good thing to have for this section, because there are going to be some things that are going to overlap, so it's nice for us to be able to color code everything. I'm a big fan of using color, so. All right, so let's talk about how do we graph a linear inequality in two variables. So if you need to, you can look at how do we graph a linear inequality in one variable. You can look back at my MAT 0022 class, chapter 2, section 9. That video talks about how to graph a linear inequality in one variable. But today we're going to talk about how do we do two variables. So your linear inequality is going to be, it might be in standard form, and it's going to have, if it's in standard form, it's going to have one of these four symbols: a less than sign, a greater than sign, less than or equal to, or greater than or equal to. A, B, and C are all going to be real numbers. A and B cannot both be 0, though. That's the important thing. You have to have, because if you multiply 0 times a variable, it'll go away. So you have to have at least one variable, right? It has to be at least X or just Y. You know, those are vertical and horizontal lines. And your answer is going to be a bunch of ordered pairs, because we're going to have a lot of different ordered pairs that could satisfy this inequality. So it's really hard to actually write mathematically what the answer looks like. So in this case, graphing your answer is going to make the most sense. The graph is going to be the best representation. So I'm going to walk you through a couple of examples just so you can see what this looks like. All right, you know what, here's the checklist. I think it's just easier if I just tell you how to do it. If you would like to take a screenshot of this or whatever, please feel free to do that. But this is what I'm going to talk about, these 3 steps of how we actually graph a linear inequality. So I'm just going to skip forward past this. All right, so say this is your equation. Now, we have to review a little bit about graphing lines. Remember when you were graphing a line, if it's in standard form like this, that it's definitely easier to use intercepts. So that's what I'm going to do. I'm going to plug in x equals 0 first, and if I do that, this is going to go away, and I'm going to be left with 2y. And I'm just going to put an equal sign because I'm not really worried about the inequality sign quite yet. So that tells me that I have a y-intercept of -7. So I'm going to go to my graph, and at 1, 2, 3, 4, 5, 6, 7, y equals -7, I'm going to put a dot because I know that that is going to be my y-intercept. And then I'm going to do the same thing. I'm going to do my x-intercept. So I'm going to put a y is 0 this time, and I'm going to get 7x is equal to, again, just pretend it's an equal sign, -14. Divide both sides by 7. That means x equals -2. If you need a refresher on how to graph using intercepts, please go back and look at section 3.3. That's when we talked about that. So definitely take some time. Okay, so those are my 2 intercepts. Now let's look at that sign. Okay, notice this symbol is strictly greater than. There's no equal to. So if there's no equal to, then we are going to draw the line, but we're going to draw it dotted. So we're going to draw the dotted line through those 2 points. All right, so there's my dotted line. Okay, now because it's greater than or less than, that means we're going to have some shading to do because there's going to be lots and lots of points that could possibly satisfy this. The easiest way to do that is to test the origin if the origin is not on the line. So I'm going to test the point 0, 0. Notice 0, 0 is not on the line, so that's good. It's not on this dotted line. So we're going to test this. If we test this point and it comes out to be true, then that means that this whole section over here is going to be shaded. But if we test this point and it is not true, that means everything over here will be shaded on the opposite side. So let's I'm going to test 0, 0. So I'm going to go back here. I'm going to plug in 0 plus 0. Is that greater than -14? And that is true, right? 0 is greater than -14. So that means because 0, 0 is true, that all these points over here are all shaded. That means any point over here will work in this inequality. So notice mathematically it'd be really hard for us to write that. So that's why this picture represents So anything in this shaded region over here, any point over here will work. And feel free to test a couple, like choose one that's really like really far out there. Like if you did the point 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so if you did this point, 5, 5. Okay, according to what we've done, 5, 5 should work. So if I plug in 5, 5, I get 35 plus 5 times 2 is 10. Is 45 greater than negative 14? Absolutely, right? So it checks out. So feel free to test a couple points just to make sure that you've shaded the correct area. But your answer is going to be this picture. It's not going to be an actual written answer. Your answer will be the graph itself. So when you are doing these on my math lab in your homework, it does take a little finagling and getting used to. So make sure that you leave yourself a little extra time to do this homework, because it is going to require you to use my math lab and that tool with the graphing tool at the bottom. So just, again, take your time and don't throw your computer out the window if you get frustrated. All right, so here's another example. If you'd like to try it, go ahead. If you think you know what you're doing. For the rest of us, again, we are in standard form, so I'm going to continue using my intercepts to graph. So if I plug in x equals 0, I get 5y equals negative 2. And if I divide both sides by 5, I get negative 2/5. So this is kind of not a great thing because we do have a fraction, but I'm going to go with it. Negative 2/5 would be like about here. And again, we are going to try to be nice on the test and make sure that all the numbers come out nice and pretty whole numbers so it's easier for you to graph. In the homework, that won't be the case because they're randomly generated. So please realize that you may get some fractions. So if you do, don't panic. Okay, just you guys know what you're doing. All right, let's plug in at y equals 0. So I get 3x is equal to negative 2. Again, I get another fraction, negative 2/3. So an x value of negative 2/3 would be about right here. All right, so then I'm going to draw my line. Now notice I have a less than or equal to. So the line is included because it's equal to that line. So we're going to draw, oh, and of course, I hope your lines are going to be much straighter and better than mine. I'm doing mine on a computer screen, so if you want to use a ruler, that'd be great. When you use My Math Lab, it'll put it in there straight for you, so you don't have to worry about having horribly ugly lines like I do. All right, and then we're going to test just like we did before. So we're going to test 0, 0. Because I noticed the point 0, 0 is not on the line. It's just right above it, so that's good. All right, so if I plug in 0 here, plus 0, is that less than or equal to negative 2? And that is false, right? 0 is not less than negative 2. It's greater than negative 2. So this point should not be shaded, which means the other side. So this whole other side, the opposite side, should be shaded. So there you go. There is your graph for this one. Notice a solid line because we had the equal sign right there. And then the shading underneath, because when we tested 0, 0, it did not work. So this cannot be the shaded side. It's got to be the other. All right, and again, if you want to test, take this point, negative 4, negative 4, okay? Plug that point back in, it should work, okay? Negative 4 times 3 is negative 12, so negative 12 plus negative 4 times 5 is negative 20. So is negative 20 plus negative 12 less than negative 2? Less than or equal to? Yeah, it is. Okay. So this is on the shade. We did shade on the correct side. So feel free to test as many points as you want, but all of the points in the shaded area are the answer for this problem. All right, next example. Notice in this one, there's only one variable. Okay, so if you only have one variable, the first thing you definitely need to do is to get that variable by itself, because we know that this is going to be one of our special cases. Right? If it's just x, we know that it is a vertical line. So we are going to draw a vertical line at x is 5, but notice it's going to be dotted, right? There's no equal sign underneath it. So this is going to be a dotted vertical line. Okay, and we want x is less than. If we're doing x is less than 5, we're going to the left. So everything to the left is going to be shaded, nothing to the right. So it's all going to look like that. All of these points are all going to be shaded. The nice thing about vertical and horizontal lines is you don't really have to do a test point because it's going to be straightforward. It's either going to be less than, which means we're shading to the left, or greater than, we're going to shade to the right. If it's a horizontal line, you would shade, if it's y is greater than, you would shade above, and if it's y less than, you would shade below. So like, I'll just do the same example on here. Like if you had y is greater than or equal to -2. Okay, so here's your line y equals -2, right? So that'd be solid. And then y is greater than, meaning you'd be shading up like that. So yeah, vertical and horizontal lines are definitely a little bit more straightforward than the ones that are on a slant. So if you have a slope, a positive or negative slope, then you're definitely going to have a little bit little more trouble. But when it comes to vertical and horizontal, it's very straightforward. All right, and again, just a warning, if your line is actually sitting on the point 0, 0, if it's on the origin, then you can't use 0, 0 as your test point. You can use any other point though. So you could use 5, 5, you could use, you know, whatever you want, 1, 1. But just note that if your line is goes through the origin, you can't use that as your test point. All right, the next thing you're going to be asked to do is to solve a system of linear inequalities. What a system is when you're graphing more than one at a time. So you're going to do 2 of these on the same graph, and this is where color coding is going to be your best friend. Okay, so you're going to, and this is just, and I took these instructions right out of your textbook. So a system is just, you're going to graph both of the inequalities at the same time. And then the solution is going to be the place where they overlap. So you're going to have the overlapping shaded areas. That's where your answers, because those answers in that double shaded area are going to satisfy both inequalities at the same time. And that's what we want, because if you have a system, your answer has to satisfy both of the equations. So again, let me just show you a little bit easier. All right, so here's your first one. This is in slope-intercept form, which I like, right? So if you don't like it this direction, y greater than 2x, notice the alligator's eating the y, so the alligator's still eating the y. This tells me I have an intercept of 0, and then I have a slope of 2. So I'm going to go up 2 over 1, up 2 over 1. Oops, I shouldn't draw that in there. Hold on, let me erase that. I shouldn't draw the little steps. Okay, so up 2 over 1, up 2 over 1. Okay, so this is going to be your line. And again, it's going to be dotted, right? Because we don't have an equals, so it's going to be dotted. And if you want to go backwards a little bit, it just kind of helps. Okay, so that's your first line. Notice when we're shading this one, we can't use 0, 0 because it's a test point, because it's on the line. So maybe choose the point 1, 1. Like I notice 1, 1 isn't on here. So if I test 1, 1 on this one, 1, I get 1 is greater than 2. Is 1 greater than 2? Definitely not. So 1, 1 is not shaded, so that means I have to shade up this side. So the other side of the line will be shaded. Okay, so there is the graph for that first one. And then I'm going to do the other one in blue. Okay, so this one also, I'm going to put this one also in slope-intercept form, just because I think that's the easiest way to graph. All right, so we have slope-intercept form. We have a y-intercept of +5 and a slope of -5. So we're going to go down 5 over 1, down 5 over 1. This one also does not have an equal sign, so it's going to be dotted as well. So we're going to do a dotted line through here. Okay, make sure you have your arrows on the end. And then we can test 0, 0 this time, because notice 0, 0 is not on that blue line. So if I test 0, 0 in the original, I get 0 plus 0 is greater than 5. And that is definitely not true. So the 0, 0 is not shaded, so that means this direction should be shaded. Now notice, when I do this shading, I get an area that's double shaded. So notice this area right here is the double shaded, that little triangular piece. Okay, so that is my answer. Any point in that little triangular area will satisfy both of these inequalities at the same time. So if you choose any point in there, and if you want to, pick one. Like it looks like the point 1, 4, right? 1, 4 is right here. So the point 1, 4 should satisfy both of these. So 1, 4 would tell me that 2 is less than 4, which is true. And if I put 1, 4 in here, I get 5 plus 4 is 9. I get 9 is greater than 5, which is also true. So it checks out. So we know that that little triangular piece is the answer. Only points in that little triangular piece. So you just got to be really careful when you graph these. It's a lot of attention to detail because you've got both of those graphs appearing at the same time. All All right, so if you want to try one, go ahead and press pause. All right, for the rest of us, we are going to continue on. For those of you who paused, welcome back. All right, so I'm going to do this one with intercepts because they're both in standard form. So if I put a 0 here, that would give me y equal to 9. Oh, and that's too far on my chart. Uh-oh. I had a bad choice of chart here. You know what? I'm going to pause for a moment, and when we come back, I'm going to have the correct chart. All right, now we have the correct graph here. Sorry for that. All right, so if we go back to our original, let's go back to, okay, we're going to start with this first one. If we plug in x equals 0, we get a intercept of 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 would be right here. And then if we plug in a 0 for y, we get 3x equals 9, which would give us an x-intercept of 3. So there's our two intercepts. It's going to be a dotted line because that's a less than. So dotted line between those two. And then you're going to test 0, 0. By plugging 0 plus 0, is that less than 9? It is. So that means everything on this side should be shaded in. All right, so that's all going to be shaded. Okay, then we're going to go to the next line. Okay, so this line, we're going to do the same thing. I'm going to plug in x equals 0. I get 5y equals 10, which means y equals 2. There's my y-intercept. Then I'm going to find my x-intercept by plugging in y equals 0, and I get 2x equals 10, which means x equals 5. 1, 2, 3, 4, 5. Okay, so there's my intercepts. This one does have an equal sign, so it's going to be a solid line through those two. So solid line. Okay, then I need to test 0, 0 to find out which way I'm shading. So 0 plus 0, is that greater than or equal to 10? It is not. So 0 should not be shaded. So that means that this whole section above the line should be shaded in. All right, so again, you've got some overlap, right? Your overlap is in this triangular area right here. Okay, all right, so this whole triangle that I'm now shading in yellow. Anything in that triangle is your answer. That is the overlapping area. Anything in there, any point in that yellow area will satisfy both inequalities at the same time. These do take a little bit of practice, so don't get discouraged. There's a lot of details involved. Are the lines solid? Are they dotted? Where do I shade? All that stuff. So there's a lot of stuff that goes on in these problems. All right, here's another example. Notice both of these are in slope-intercept form, so that's very nice. So this one, you're going to have a y-intercept of 4, and it's going to have a slope of positive 2, so it'd be up 2 over 1. I'm just going to go backwards because I don't have enough space here. Notice it's dotted because there's no equals, so dotted. And then I'm going to test 0, 0. So is 0 greater than 0 plus 4? That is not true. 0 is not greater than 4. So that means I would shade all this space over here. All right, and then I'm going to go to the other one. This one has an intercept of negative 2, so right there. It also has a slope of 2, so up 2 over 1, up 2 over 1. So notice those are going to be parallel because they have the same slope. Oops. And then I forgot to make that a dotted line. There was no equal sign. All right, so there's my dotted line. I'm going to check 0, 0. 0 is less than 0 minus 2. So is 0 less than negative 2? It is not. 0 is greater than negative 2. So I shouldn't be shading here. I should be shading this way. And notice, okay, in this graph, do I have any overlapping area? Okay, notice I do not. Those do not overlap. So because there's no overlap here, the answer is no solution. There is no point that will satisfy both of these inequalities at the same time. And remember, your symbol for no solution is a 0 with a forward slash. So you can see it either way. You can type no solution, or you can put 0 with a forward slash. So this could happen where you get no solution. There is no overlap. That is a definite possibility. It doesn't happen very often, but it can happen. So keep that in mind. All right, and one more example. So if you would like to try it on your own, go ahead and press pause. So here we go. The first one is in standard form, so I'm going to use my intercept. So if I plug in x equals 0, I get a y-intercept of 2. If I plug in y equals 0, I get an x-intercept of negative 5. All right, that's going to be a dotted line because there is no equal sign on that inequality, so dotted line. I'm going to test 0, 0. So is 0 plus 0 less than 10? Indeed it is. So I know that that side where 0, 0 is that's the shaded side. All right, so there's your first one. And then we're going to go to the second one. The second one, y is less than or equal to 3. Notice this is a vertical line. So we're going to draw, a vertical line, horizontal line. Hello, it's been a long day. All right, horizontal line at 3. It is equal, so it's going to be a solid, right? Solid, got the equal sign there. And we're going to do y is less than 3, which means we're shading below. So notice this time we have a very large overlapping area, right? We've got starting right here it overlaps, and then we kind of take a little turn here, and then all this. So all of this in this area is all overlap. So any point in that yellow shaded area will work for both of those inequalities. All right, so that ends our work for chapter 2. Please feel free, again, you may need to practice your graphing a little bit more. So if you need to practice your graphing, you can go back to the previous sections at the beginning of chapter 3. That was sections 2, 3, and 4. And practice all that graphing of lines and then come back and try this again. But you really have to know how to graph lines before you can do any of this stuff. All right, so that ends Unit 2. Thank you so much, and we will see you for the test.